Hello guys. So this is gonna be my first video um, to help you in math. Let's begin with our lesson on area and perimeter. Okay. So to begin with this discussion, I'd like to say that this video is recorded for the purpose of helping those who are having a hard time coping up with the math lessons. So if you find the lesson on area and perimeter a concern, then this is a video that you should watch. The next video will be also area and perimeter, but will be focusing more on triangles. And then following that would be a video also about circles before moving on to the other lessons. So now let's begin. Area and perimeter. Area is said to be, by definition, area is a space, a two-dimensional space, and we can compare this to the space of a room, a classroom, or a land space, or a land area, or probably the area of your room. So that's a two-dimensional shape. Whereas perimeter, on the other hand, is the outline of any geometrical shape, geometrical figure. It's kind of one-dimensional when we talk of perimeter. It's just single dimension. So let's define what do we mean first by dimension. When we say dimension, this literally means dimension. This literally means a measurement. So when you say a line going on that direction, or actually that's a ray, this is another line, this is another line, all of them, if you would notice, is only a single measurement. If you use a ruler, you can basically measure this in this manner. Okay, use a ruler here or a meter stick, and then you can measure it in that manner, and then this one in this manner. So it can be measured using a single measuring tool. It uses only it only follows one line or one dimension. That's what we call as one dimension. What about 2D? Okay, you sometimes hear about 2D. 2D refers to an area, a flat space. So let's talk of a single dimension going here and probably another dimension going there. So those are two dimensions. And if you think about it, oh, that's kind of like a space, because this line that I'm drawing right now, this line is literally a copy of that. And this line here can be copied there. Now, as you may notice, that's a space. That's like a sheet of paper. That's like the base of your room. That's like a land area where you can put a house. Okay? This one going there, and this one going there. You copy that. So that's just a copy of the one at the bottom, and this a copy of the one at the left. That's also a space. So space or area or 2D images can have so many examples. These are what we call as geometric figures, a 2D geometric figure. You can have here a basic square, a rectangle, you know this, a triangle, maybe a trapezoid or trapezium. You can even have other figures, a parallelogram, and others. So that's a 2D. And when we talk about 3D, well, that's gonna be 3 measurements. So say for example, we are going to have to begin from that point, and then this is going to be one dimension. This is going to be the second dimension. And that's going to be your third dimension. What do we mean by that? So this line here, we can write it here. That. This line in here, we can copy it just like the one we did previously, and then it can be here. And then finally, this line in here can be written at all corners of this 2D image. So therefore, that's going to be this, this, and this. And now you can see that, oh, that's actually a three-dimensional image. So that's what we mean by dimension. It's just the number of measurements that we are making to create these figures. So 1 dimension refers to a line, 2 dimension refers to an area, and then 3 dimension, it can be represented using the word, I think you know this, volume. All right. Now, going back, what is an area and what is a perimeter? Let's look at this 2D image first. By definition, we call this a rectangle. This rectangle would have a measurement of what? Let's count these units. That's 1, 2, 3. So that's 3 units. Let's define each unit as a meter. Let's, for the sake of this example, that's 3 meters. This one will be 1, 2, 3, 4, 5, 6 meters. Now, think about that. 6 meters and 3 meters. If we're talking of the area, or let's begin first with perimeter. Let's talk about the perimeter. Perimeter is the total length of the outside or the outline of the figure. Then you can have here 6 plus 3 plus another 6 plus another 3. That would lead you to 6 plus 3 plus 6 plus another 3. That's a total of what? That's a total of 18 meters. How about the area? The area represents the space inside this figure. So that's the area. That's what we call as the area. Looking at the figure, how much space are in there? Let's look at that. This is gonna be 1 meter by 1 meter, because this is 1 meter and this is gonna be another meter. Then putting it together, 1 meter and 1 meter is equal to 1 square meter. So how many 1 square meters are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 square meters. The area is equal to 18 square meters. Surprisingly. So 18 square meters. Now, it may be difficult if we are solving for the area and we are talking of something, maybe something bigger, right? Maybe if we are going to make an illustration of that, let's just say, what if the figure is like this? Okay, that's 6 here, and let's just say that's 21 here. There should be an easy way on solving for area, on how to solve for area. And solving for that we would have to look at the length here and the height there. So the base here and the height there. And what can we do to the 3 and to the 6 so that it will end up to becoming 18? 6 meters blank 3 meters is equal to 18 square meters. What operation can we do here so that it leads here? Well, if you think about it, the only logical answer is it cannot be a plus sign, it cannot be a subtraction sign, it cannot be a division sign, it can only be a multiplication sign. So what we are saying is an area, in solving for the area of a rectangle, area of a rectangle can be solved using the formula base times height. Okay, let's try it one more time. What about here? This is not a rectangle, this is actually a square. But can we use the same formula? This is 1, 2, 3, 4. That's 4 meters. 1, 2, 3, 4. That's also 4 meters. So this is a square. Area of a square is equal to, well, let's try that formula now. Base times height equals 4. That's 4 times 4. And the area of a square is equal to 16 meter square. So is that correct? Let's see. Let's figure out if that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 squares. There are 16 meter squares in that figure. So this should be correct. What about the formula for the perimeter? Is there a short way to do that? Well, yes, actually. For the perimeter, the only formula that we have to look at is, well, for a square, the sides here, 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 and here are all identical. So that should only become perimeter of a square equals 4 times the side. Perimeter equals 4 sides equals 4 times 4 equals, no. Yeah, that's correct. 4 times 4, that should be equal to 16 meters. Look at the unit, it's meters because we did not measure it in 2 different dimensions. We just added all the lines. So this is the same as 4 plus 4 plus 4 plus 4, which is still equal to 16 meters. Okay? Next. What about this? That's 1, 2, 3. This is 1, 2, 3, 4, 5, 6. If we are going to solve for the area of this, the answer will be base times height, which is equal to 3 times 6. And that should be equal to, again, 18 meter square. Perimeter. This is going to be base plus height plus base plus height, or just base plus height times 2. So that's going to be 3, as you may notice. It's 3 here, plus 6, 3 plus 6 plus 3 plus 6. So a total of 18 meters. So you may say, okay, so is it always gonna be that the perimeter and the area are always represented by the same numbers? That is a good observation, but that is not really the case in all instances. You will see a lot of exemptions to that pattern that you may be seeing right now, but this is basically how to compute for the area and perimeter of rectangles. I'll see you in the next video for the area and perimeter of triangles.